Okay, so this lesson is actually really similar to the last lesson. I can't talk. We're just doing the alcohols, except the difference is that aldehydes and ketones are actually double bonded to the oxygen, when the alcohol we were working with before was only single bond. So we just have to remember to put double bonds. And let's go into the first one. So we have an aldehyde. So we know that the oxygen is going to be attached to a carbon that's only attached to one carbon or no carbons. So we have our carbon, and then we have our double bond to oxygen. And I'm going to add my hydrogens and hit arrange. And this is actually our simplest aldehyde. So this one, we just have to remember it. And then on mine, it asked me for formaldehyde, and then it asked me for methanol. So if it asks you for methanol, it's just one carbon with an oxygen attached double bond. And it's the same thing as formaldehyde. Okay. And a ketone can be recognized by the oxygen being attached to a carbon that has two other carbons attached to that one. So if this was an aldehyde, this would be right here, or we just wouldn't have this methyl group. So we start by naming this the longest chain, 1, 2, 3, 4, butane, and then with the ketones, you want to specify what position it's at, since it can't start at the first position, since that would be an aldehyde. For ketones, you have to specify the number. So it's on the 2 position. We're going to look for any chiral centers. This carbon has 2 hydrogens, 3 hydrogens here, 3 hydrogens here. And this can't be a chiral center because it only has 3 molecules attached, whereas it should have 4 to be a chiral center. So butane to one, it's the ending in ketone, so we want to use that. Okay. Okay. So we're gonna start by drawing the butane. So it's 4 carbons. And then it ends in Al, so we know it's gonna be an aldehyde. So that's gonna have an oxygen attached, double bonded to the first carbon. We also see that there is a methyl on the 2 position. We start counting from oxygen because that's the first priority. So 1, 2, and then of course 3 and 4. Add our hydrogens, hit arrange and roll. And we see R, so we have to decide if this is R or S conformation. So this one is going to be our highest priority, and then the long branch, and then this one. So R, so this would be R, since it's going clockwise. And then just to show how I counted, you go 1 bond out, you get 1 carbon, 1 carbon, 1 carbon, same bond, so our same priority, so we go out 1 more. So we get double bonded oxygen, so that counts as 2, and then our hydrogen, and then we get 1 carbon, 2 hydrogens. 2 oxygen beats and a hydrogen beats, or a double bonded oxygen and a hydrogen beats 1 carbon and 2 hydrogens. So this would be 1, 2, this would only be 3 hydrogens, so that's why it's last. So R, let's see, okay. That's zoomed in. Okay, so the carbon is only attached to the oxygen, no other carbons, so this would make it an aldehyde, and it would be our simplest aldehyde. So we can either put formaldehyde or methanol, like I was talking about earlier. So let's try that and see if it works. Okay, and you could also put formaldehyde, that would also give you the correct answer. Pentanol, so this one's pretty easy. The aldehydes are probably the easiest. So you get your 5 chain. double bonded oxygen, add your hydrogens, and that's it. The aldehydes are easier because you don't have to do anything with the numbering scheme or anything, unless you have methyls attached. Okay, so you're going to start by drawing butane, and then it's an aldehyde for the Al, so we double bond that to an oxygen, and then now we add our methyl group. That's at the 2 position. We start counting here because oxygen highest priority. 1, 2, 2. Add our hydrogens, arrange, and now lastly, we have to check that conformation. So like we said before, this is the highest priority, this one, and this one. So this is R. So we're going to go ahead and mirror that. Now let's check it again. First priority, second, third. It's now counterclockwise, so that's the S position. So it's good. Okay. Pentane 2-on, so we know this is a ketone, so we can start by drawing our pentane. 5, 1, 2, 3, 4, 5. And then we have the oxygen at the 2 position, which makes it a ketone. So 2. And then we can add our hydrogens. Okay. And we know it's a ketone because it's got the oxygens attached to the carbon that's then attached to 2 carbons on either side. If this wasn't here, the methyl, then that would be butanol. Oh, there's butanol right here. So 4, and then double bond the oxygen, add the hydrogens, arrange, 1, 2, 3, 4, and that should be good. So on this homework, just mostly focus on the ketones because that's the hardest part, and the aldehydes are pretty smooth sailing. Okay, so we've got a ketone. I can tell because this oxygen attached to the carbon is then attached to 2 other carbons. So 1, 2, 3, 4 is the longest branch. Butane, it's at the 2 position, the oxygen. Right here, the 2 position. 1, 2, 3, and then we have a 3 methyl. And then I'm going to look for any chiral centers. Carbon attached to 2 methyls. This carbon has 3 molecules attached, and the rest have 3 hydrogens. So that should be it. Okay. Okay, we're going to start by drawing the butane, and it ends in Al, so it's an aldehyde. So I'm going to double bond at the end an oxygen, and then there's a methyl at the 3 position. So 1, 2, 3, add our hydrogens, hit arrange, and it doesn't specify RS, so there's probably no chiral center. Yep, 1 carbon attached to 2 methyls, 1 carbon attached to 2 hydrogens, and 3 different molecules right here. So that should be it. I think this is the last question, so I'm actually going to show you a different one that kind of threw me. Let's see if I can erase this. So one that got me one time was Acetal Aldehyde. And this one, to draw it, you put your carbon attached to a methyl, double bond it to an oxygen, and then add your hydrogens, arrange, roll. So this is Acetal Aldehyde. This is the one that got me before. So I just wanted to show you guys. And yeah, I don't know. I forgot what question it was that I was doing, but yep.